which is angle measures and angles. The first two problems are asking us to draw angles in standard position. Standard position means that the terminal side is rotating around while the initial side stays on the positive x-axis. So I'm going 380 degrees. 380 degrees means I'm going in a counterclockwise direction, a full 360 degrees, and then 20 degrees more. I draw on my terminal side, and then I tell my students, make sure you label the angle. When you're looking at number 26, do a conversion. Switch it to degrees. So negative 2 pi over 3 times 180 over pi. Simplifying it up, I get a negative 120 degrees. The negative means I'm going to go in a clockwise direction, starting at the positive x-axis, going clockwise 120 degrees. But when I go and label it, I label it in radians. You start in radians, you end in radians. And you're just drawing the angles where they're supposed to be positioned, depending on clockwise, counterclockwise, with positive and negative. The next group is asking us to convert each degree measure to radians and each radian measure to degrees. So when I start with degrees, as in problem 32, I'm going to multiply by pi over 180. So I'm going to take the 570 over 1, multiply it by pi over 180. Simplifying it up, I get 570 pi over 180. But as advanced algebra students, you should always simplify your fractions. So when I simplify it all the way, I'll have 19 pi over 6 as my answer. Looking at problem 38, I'm taking negative pi over 3, and I'm going to be converting that to degrees. So I take my negative pi over 3. When I convert to degrees, I multiply by 180 over pi. A pi on the top will cancel out a pi on the bottom. So I have a negative 180 over 3. Simplifying up, I get a negative 60 degrees. Don't forget the degree symbol, and don't lose the negative sign. And then the last one, number 41, is a 9. A 9 doesn't have a degree symbol, so that means it's already in radians. So I have to convert it to degrees by taking 9, multiplying it by 180 over pi, and then simplifying it up. Now when students multiply and simplify up, they get 1,620 over pi. That's where they leave it, but that's not in degrees. I need to divide by pi yet, and when I divide by pi, I get 515.7 degrees. Again, don't forget the degree symbol. And then our last two examples. Find one angle with a positive measure, one angle with a negative measure, coterminal with each angle. What it means by coterminal, again, is that they're going to be rotated around either in a positive or negative direction, a full 360 degrees or 2 pi. You need to remember that 360 degrees is the same as 2 pi, one full revolution. So on problem number 47, I'm going to take my 368, I can add 360, and when I add 360, I come up with 728 degrees. There's a positive coterminal angle. If I take my 368 and I measure 360, I come up with 8 degrees. You can't stop there. That's still a positive coterminal. There's multiple answers that are always possible. Here's 2 positive coterminal ones. In order to get it, I have to take that 8 degrees and I have to subtract another 360 to get my negative one, which means I'll have a negative 352 degrees. So positive answers possible would be 728 for degrees, 8 degrees. A negative one would be negative 352. Now, when you're looking at problem 51, you still have to add or subtract a 2 pi, which is 360 degrees, but I need a common denominator. So when I'm looking at 2 pi here, because my denominator is a 4, remember 8 pi over 4 is the same as 2 pi. So I'm going to take my negative 5 pi over 4, I'm going to add 8 pi over 4, and I get a positive 3 pi over 4. There's my positive coterminal angle. Then I'm going to take my negative 5 pi over 4, and I'm going to subtract an 8 pi over 4. And when I do that, I get a negative 13 pi over 4. There's my negative. Again, with problem 51, if you start in radians, you need to end in radians. You cannot give me an answer in degrees, because I started in radians, I need to end in